Hello guys, in this video we're going to look at some exponential graphs or properties of the exponential type graphs, and we'll go straight into an example. So here we have y equals a half to the power of x. Now again, to get a feel for what this might look like, let's draw a table of values. So we have our table of values here, and we have x and y. Again, we're going to go from -3 up to 3, just so that we get an idea of what it might look like. Okay, so here are our table, or here is our table of values. And from here, let's start evaluating what y would be. So, if x were equal to 3, then y would be a half to the power of 3, which is an eighth. If x were equal to 2, then y would be a half to the power of 2, which is a quarter. If x were equal to 1, then y would be a half to the power of 1, which is a half. If it's 0, then you get 1. If it's -1, then remember from laws of indices, that's the reciprocal, so that's just 2. If it's -2, then that's the reciprocal and squaring, so that becomes 4. And if it were -3, it becomes 8. You might notice that this is similar to our other video where we did y equals 2 to the power of x. At some stage later on, we'll have a look at why there are similarities, because it's no accident. But for now, we're just going to look at what this graph would look like. So we have our table of values, and now we're just going to get our set of coordinate axes. Okay, so here we have our coordinate axes, and we're going to plot. So if we go from here, from x equals -3, we can see that that's where y is equal to 8. If it's -2, we get 4. If it's -1, we get 2. If it's 0, we get 1. And for the other values, it continues to halve. It gets closer and closer to the x-axis, and again, never touches it. If we think about it, if we raise a half to the power of a really big number, then it's just going to get really small but never actually get to 0. So we have another situation of an asymptote. And just to draw that nicely, connecting these points together, we get something that looks like this. Something that has this rough shape. So this is actually symmetrical to our y equals 2 to the power of x, where this y-intercept is 1, and of course we still have the x-axis as an asymptote. So let's just put this here. If you have the y is equal to a to the x, where a is a constant and is strictly between 0 and 1, then we have that our exponential graph would look something like this. Okay, so again, we have that our asymptote is y equals 0, or the x-axis, and of course the y-intercept is equal to 1. Okay, and that's it for this video.